Hi, welcome to the second video in the polynomials topic. What we're going to look at today is dividing polynomials. And by the end of the video, the two things you want to be able to do is be able to use synthetic division to divide a polynomial and identify the divisor, the quotient, and the remainder from a synthetic division. Now, what we're going to look at first is a nice easy one. We're going to look at primary school sums 29 divided by 8. Now, 29 divided by 8 from primary school would be 3 remainder 5. Now, what that really means is that if you want to build 29, you can do 8 multiplied by 3 add 5. Just looking at that sum from a different perspective. Now, these three numbers in here have very specific names. That 8, we will already know that's called the divisor. That's what we're dividing by. The 5 at the end, that's your remainder. We already know that as well. That's what's left over. But that 3, we may not have heard, is something called a quotient. And what we want to be able to do is, using dividing polynomials or by dividing polynomials, split a polynomial up into its divisor, its quotient, and its remainder. Now, as we did with more complicated sums in primary school, this is a more complicated sum. We're going to use long division. Okay, now I don't want you to copy anything down here. I just want you to follow along as best you can. It's not going to be pretty, so you need to bear with me. We're going to divide x minus 2 into 5x cubed plus 2x squared plus 8x minus 2. Now, to do that, what we want to do is we want to find a multiplier that makes x minus 2 go into 5x cubed as best we can. Now, that's going to be multiplying by 5x squared to give us x turning into 5x cubed. So if we multiply this number here by 5x squared, it gives us 5x cubed minus 10x squared. And then we're just going to do a subtraction here. So 5x cubed, take away 5x cubed, disappears, so that's good. 2x squared subtract negative 10x squared will give us 12x squared. Next, we want to multiply this to get to this. So x multiplied by 12x will give us the 12x squared we want. So that'll be 12x squared, and then multiplied by the negative 2 will give us negative 24x. Now let's bring that plus 8x down there as well, so we've got a nicer subtraction. So 12x squared subtract 12x squared disappears. 8x subtract negative 24x will give me 32x. Then same again, I'm going to multiply by 32 this time to get 32x. And then that second one here is going to be negative 64. I'll bring the negative 2 down from there. And when I do my subtraction, that disappears, and that leaves me as positive 62. Okay, now I'm just going to make that a little bit smaller so we can work here a little bit more comfortably. That is a synthetic division, or that is a division, long division with a polynomial. And what that really means is, at the end of the day, your 5x cubed plus 2x squared plus 8x minus 2 is going to be equal to a divisor, which here was x minus 2. Your quotient, which is what we get when we divided, which was a 5x squared plus 12x plus 32, and the remainder, which was 62. Now, what we don't want to be doing is we absolutely do not want to have to do this every time we want to divide a polynomial, because it's an absolute nightmare. But if we use synthetic division with that initial polynomial, which is 5x squared cubed plus 2x squared plus 8x minus 2, and use 2 at the side, 5 comes down, 5 times 2 is 10, 2 add 10 is 12, 12 times 2 is 24, 8 add 24 is 32, 2 times 32 is 64, and then minus 2 add 64 is 62. Now what we'll see is that remainder matches up really nicely. That remainder is 62. In there, you've got your remainder. Okay, so in that box at the end, in that wee bit at the end, that's your remainder there. Also, if you look at your quotient, 5x squared plus 12x plus 32, 5, 12, 32, you're going to get your quotient from that point there. Now, all you'll need to remember is that if we start off with a cubed here, because we're dividing by a factor of x, this is going to turn into an x squared. the next one's going to be an x, the next one's going to just be a number. And the last thing here is your divisor's hidden in here as well. If your root would be x equals 2, or your value in f of 2, that comes from a bracket x minus 2, which is your divisor. Now, that there, synthetic division, is a much more efficient way of dividing polynomials and gives us much more information more readily. So that's what we're going to do here. Now, the big point here is actually at the end, that 62 at the end will always be your remainder. If you run a 2 through your function, it gives you a remainder. The byproduct gives you the quotient, and then you can easily turn it into a divisor as well. Okay, now this is going to be your note. Can you copy that in your note? And we'll give that a wee try as well. I'll go over that in a wee second. Okay, now the example here, find the quotient of the remainder for this polynomial with this divisor. Well, actually, I don't want to do a big division sum this time. I want to use synthetic division. I'm going to use my big L. Okay, it's 3x cubed. Careful, there's no x squareds. There's a negative 7x, and then there's an 8. This x plus 5 is going to become x equals negative 5. And that's going to go at the side of my synthetic division, and then I'm going to run through it. So 3 comes down, 3 times negative 5 is negative 15, 0 add negative 15 is negative 15, negative 15 times negative 5 is a positive 75, 75 take away 7 is 68, times by negative 5 is negative 340, and then 8 add negative 340 is negative 332. Now from there, we can see the quotient, which we've been asked for, is down here. So the quotient is equal, well, we started off with a cubed, so this 3 is going to be 3x squared minus 15x plus 68, and the remainder is just in that box at the end, so the remainder is negative 332. Okay, another example for your notes. Now, it's just a different way of writing this, but really that's what we were doing on the slide 2 times ago anyway. So let's look at the synthetic division with 4x to the power 4. Right, we've got 0x cubed, we've got 3x squared, we've got 2x, and then we've got 1. This x minus 1 is going to turn into an x equals 1, so 1 goes on the side, and we run it through. 4, 4, 4, 4 again, 7, 7, 9, 9, 10. Now, what that means is the function that we started off with can be written in terms of its divisor, its quotient, and its remainder in terms of, well, the divisors first, x minus 1. The quotient comes from here. This started off as a power 4, so this is now going to be a cubed. So it's going to be 4x cubed plus 4x squared plus 7x plus 9, and then the remainder comes from in here. So we've got a remainder of plus 10. Now, actually, dividing polynomials, as useful as it can be, really what we are wanting to use it for is to identify factors so we can start splitting up the polynomials. Now, up to this point, that is this video. What we're going to look at in the next video is what happens to make a factor. And a factor is something that exists when you do not have a remainder. So if we're hunting for factors so that we can split it up into factors and start factorizing, we want that number at the end to be 0. That's what we're going to look at in the next video. Thank you very much.